huge part of database integrity are the integrity constraints. And these constraints impose limitations on our data and tells our database to reject any input that do not qualify past these constraints. Take for example a table of months, and months only. Anything other than a month is a breach of integrity. These constraints are not null, which means a field cannot be empty, and any field that is left empty will not be accepted. This is very common in registration forms. The unique constraint means no duplicate inputs. A unique input cannot be reused on a different row, but of course you can still reuse non-unique fields. The default constraint does not accept empty inputs and will instead replace it with a default value. For example, if there is no specified country in the country table, you can set the default area of residence to Philippines. The check constraint sets a condition for the database, and any input that is not within the parameters of the set condition will be rejected. Say you have a list of people over 18 or are at least at a reasonable age. The check constraint will not allow for any sort of discrepancy. Next is the domain constraint, which specifies which values you can input into a field. For example, a domain of days of the week will only accept Sunday through Saturday. A domain consisting of months will only accept the months. A domain of years will only accept an integral value of 4 digits. And as with the check constraint, any invalid input will be rejected. The only difference with the domain constraint is that the values are specified. Now let's move into a hypothetical integrity language. This code is the framework of the integrity rules that we apply. The first line is the integrity rules name. The second and third lines are what we call the checking times. This tells our system where to look when we set a constraint on a particular field. The third line is of course our integrity constraint. In this particular example, our check constraint searches the student table and checks whether the student's age has a valid amount. And naturally, any invalid input will be rejected. One more thing to note is that we can further simplify these lines of code. For one, modern database systems can find specific fields without telling them where to look. As such, we can freely omit the checking times, as well as the checking location. Also, database systems by default reject any invalid input. That means we don't really need the failure clause at the end of the line. These two lines are now sufficient to serve the same function as last time. Now, let's look at a more complex example. Here we can see the not null constraint, the unique constraint, as well as the check and the default constraint. The varchar and int tags are our connectors. They stand for variable character, which means it contains letters or a combination of letters and numbers. And integer, which means it only contains numbers. Now, this code tells our database that the student name and ID cannot be empty, nor can it be repeated. Then, it checks if the student is at least 16 years of age. Finally, it sets the default country to Philippines. And that's the gist of how integrity constraints work.